All right, this is a video on array lists, which is another way to store massive amounts of information. So the first thing I have over here on the right is I want to just reiterate or remember how to build a standard array. This is an array called horses. That's a type of string array, and it's size 5, and we have to declare the type. So just the syntax of how to create an array. What happens is you get a blank array like this, and then how to put something in the array. Horses 0 equals stallion is we're putting the string stallion into the first spot. So right now that's an S. That's pretty bad, but that's stallion in the first spot. But when we print the array, what happens? So remember, there is a length. There's like a pseudo variable, or there is a variable called length in this, because arrays are not really objects, but they're kind of like objects. So they have this one variable called length that returns the physical size of the array. So right now that's going to return 5 because the length of this array is 5. So if I print every item, and then remember to get items out of a array, you just say horses I, horses 0, 1, 2, 3, 4. So if I just compile this and run this real quick, I just want to show what this will produce for you. Is, it'll print the first item, but it's going to print null, 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 because if you don't put anything in those other spots, they're initialized to null for you if it's an object type, which this is an object type. If it was an int array, these would all be zeros, because ints and doubles are automatically initialized as 0 for you if you don't put anything in them. Well, this is kind of clumsy. So then what we had to do is we only put one item in the array, so we had to come up with our own variable to keep track of how many elements were actually in the array versus the physical size. So 5 is the physical size. We've done programs where we then had to keep track of the logical size of the array based on how many elements were put in there. It gets a little clumsy. Also, to add items to this array and insert them in certain spots and shift things down or increase the size, all of those things within an array are very, very clumsy. It takes a lot of code to do that. So there is another way to store large amounts of information, which is something called an array list. So what we're going to do now is show the similarities for building an array list. So the first thing, and you can write this code down if you want, or just kind of take notes on it as we go. So we're going to build an object of the ArrayList class. The ArrayList class is a class in Java. So just how you create any, well, let's just review how to create any. So if I was creating an object of the bank account class, I'd say bank account mine equals new bank account. Just as a review of how to build any object of any class. This is assuming a default constructor, but sometimes you have to put things in there. So that right now isn't going to work. I just wanted that there to show how you build an object of any class. So we're going to build an object of the ArrayList class. So ArrayList, we'll call it names equals new ArrayList. The ArrayList constructor has a default constructor, so you don't pass anything in there. And this builds initial size of 10. But it's very cool. The ArrayList class, even though it has an initial size of 10, it will keep track of how many elements are in the array versus the physical size of the array. And there's all sorts of other cool features to it as well. So let's put something in there right now. So we're going to say, how do you put something in? Up here it was horses 0 equals stallion, and here there are methods. Since the ArrayList is actually a class, there are methods that you can use. Remember, for arrays there aren't methods. We just have to use this crazy syntax to get things in and to get things out. But there actually are methods here. So names.add. There's a method called add that you add something. So we'll say we're going to add Seaver. And that would put Seaver into the first spot. So what really is going on again is, over here is we just got a remote control called names. That's terrible. I can't use this thing very good. It gave me a size 10 array list, and I just put Seaver in the first spot. But all these other spots are blank right now. But you'll see here in a second that it won't print them out to be null. I'm not going to put them all in there, but we got all these blank spots in there right now. So there is a method. The key is there's a method called add that allows you to add something. And you don't even tell it where to add. It just adds it to the next available spot. So if I say names.add Bozo, you probably don't even know who Bozo is. I'm getting a little old. He's a famous clown. That would add it to the next spot. So what would happen in the computer is over here, it would now add it here. So the add method just adds it to the next available spot in the list. It's absolutely awesome. It just keeps adding and adding and adding. Now, if you wanted to put one in a specific spot, so you say, you know what, names.add, there actually is an add method that has 2 parameters to it, where you could add like 1 and maybe I'll put insert there. to see what happens here. So what just happened in the computer? Now, doing this with an array would take so much time. Those of you that have done the searching and sorting program where you had to add and remove and all that craziness, in an array, you would have to put that item in and shift everything down to add that one. Because right now I'm trying to add insert right in here. I want this no longer to say bozo. I want it to say insert, and I want bozo to go there. But this one line of code just did that. Like with an array, that would take all this shifting everything down, moving things out of the way, increasing the size of the array. This thing, there's an add method that you pass where you want to insert it, and then what you want to insert. So remember, the indices here are the same. This is index 0, 1, and 2. So I just added insert to the first spot, and it actually shifted things down. So this is a great way. I'm just going to put a comment here. This is a great way to insert something. There's not an insert method. That's what a lot of people think. There's not an insert method. It's an add method. So the add method is actually overloaded. If you just pass one element, it adds it to the end. If you add, or if you pass the add method that passes an int and an object, it adds it or inserts it at that spot and shifts everything down. It's pretty cool. So now let's write the famous for loop then to test this out. So we're going to say int I equals 0. I'm having problems typing here. I is less than names dot. Here's a new method. So up here it was horses dot length. It was a length variable inside of arrays. But for ArrayList, there is a size method that tells you not just the physical size. It doesn't give you the physical size. It's awesome. It actually gives you how many elements are in the array. So even though the physical size of this array list is 10, names.size right now will be returning 3 because it's just keeping track of how many elements are actually in the array. This thing is awesome. Absolutely awesome. Okay, and then we do I++ just like we did up there. So notice a little bit of subtle differences there. And then how would we get everything out of there? Well, notice up here we use the square brackets to get things out. We say horses square bracket I. Well, in an array list, you say the name of the array list dot, and then you say get. There's actually everything's got to be a method because array list is an actual class. So names dot get I, and the get method accepts an index and it just gets out each item, or it gets out item I, and we're looping through it right now. So let's see if this works. I'm just going to put a debugging statement here. That says printing array list, just so we can see it when we actually go through and do all of this. Hopefully I have no, it's worried about me, and we'll talk about that warning. Actually, I'll compile that again. If you ever see this, this is a warning. Warnings are like, ooh, be careful, but it will still work. It'll still compile, it'll still run, and we'll talk about what all that means once we get through a couple of these things. So now we're going to run this thing. So notice that is not what I expected. I must have did something wrong. All right, give me a second here to figure out what I did wrong. Because that is not what I expected. All right, we're back here. I made the easiest mistake as well. Names.getI will get the items out, but we didn't actually print them, so nothing's showing up to the screen. So I forgot to embed this inside of a print line statement. It took me a little while to figure that out. But notice the difference between how to get something out of an array, which is up here. You say horses I, and down here you use the get method. So ArrayList is an actual class in Java that you can create objects of and use methods. So we're using methods. So right now we've learned about 4 methods. There's an add method that accepts just an object, an add method that accepts a number or an int and an object, and it inserts it and shifts everything down. We learned about the get method, that you pass an int and it will get the object out at that specific index. And we learned about the size method that returns the number of elements that are in the array. So just as a quick thing, again, we'll show this. Hopefully it'll work this time. It gives me that warning, which we'll talk about here. So now notice it's printing, even though the original size of the array list was size 10, it's only printing the 3 items that are in the array because the size method actually returns the number of elements that are in the array. Pretty cool, pretty cool. And notice how it inserted that one. I didn't have to do any shifting. I just called the add method and it inserted into that first spot. Absolutely awesome. So what are some other things? What are some other methods that are in there? So we're going to do a couple other methods here now. So let's remove something. So if you want to take something out, let's suppose I wanted to take out insert now. Names.remove, and I'm going to pass 1. So there's a remove method that you pass the index of the item that you want to remove, and it actually takes it out and shifts everything down and subtracts 1 from the logical size of the array. It's unbelievable. So that just took insert out. Right there, that one line of code would remove it. You can also set specific spots. What if you want to put the first one to be called first or something? There is a method called set that you pass the index of what you want to set, and then you put what you want to put in there. Now notice, what is this one going to do? This replaces an item from the list. Okay, so it'll take the item that used to be there. So right now it looked like we had Seaver in the first spot. So Seaver should now be gone, and it just put first in there. So that method, and I'll put it over here, just kind of came over here. We've done a couple of things here now. Let's see if I can get back to my drawing board here. So when we did the remove, it took out insert and shifted Bozo down here like this. So now Bozo's sitting in there, and the size of the array is size 2, but the last index is 1. And then we said set 1 to first, so we didn't even set 0 to first. So then we said, you know what, take this first index and set it to be first. So it actually replaces it and makes it the word first in there right now. So the set method does not insert, it actually replaces. The add method, when it's overloaded, actually, so notice the difference between add and set. Okay? Now the cool thing about the set method is it actually returns the item that was there. So if you wanted to store what was in there, you could do this, because what's coming out, or what it's actually replacing, it returns as a value. Okay? And all of this can be found in the API. So maybe we'll take a quick peek at the API real quick. So this is the ArrayList class. And we'll talk about that capital E here in a second. So notice all these methods in here. Here's the add method that we just used, and it says E, and we'll talk about that. Here's its overloaded add method. It accepts an int and an E. We won't worry about those other methods. So I'm only trying to show you the ones that you'll be responsible for. Here's the get method. You pass an int. There is an index of method that you pass an object, and it will return the place of where it's at. We've used that in strings before. Here's the remove method that we just talked about. You pass an int, and it removes the item and shifts everything down for you. It's awesome. So you just pass the index of where you want to remove. It takes that object out, but notice it actually returns what was there. This big E over here is the item that used to be there. So the remove method actually returns what was there in case you want to do something with it. Maybe you want to take it out, but then also do something with the thing that you took out. I'm thinking of a card or a deck of cards class. Maybe you want to take off the first item, but not just remove it from the deck, but also do something with that removed item. So it returns what it removed. There also is a remove method that you can pass the object, and it will search for that object in the array list and remove that object. So you don't have to pass the int, you could actually pass the object that you want to remove. And that returns a Boolean, whether it removed it or not. There's the size method that we've been using. Here's set. Notice it replaces the element. So it takes what was at this index and replaces it with this, but notice it does return. This capital E over here is it's returning what was there. In case you want to replace something and do something with what was there, you can do that. So those are the methods that you're going to be responsible for, the ones that we just went over right there. So that's what we're doing over here. Okay, now the problem with this right now, I'm assuming I'm going to get an error message here. Yeah, well, I got a warning first, but then I got this incompatible type. So I love this because you're like, wait, you're just trying to set 1 to first and take what it's replacing and storing it into X, and X is a string. The problem is, and this is going back to the beginning of Java, when array lists were built, if they're built like this, that means they can store any type of object. The only drawback is array lists can only store objects, but they can store any type of object. So I could store different types of objects in this array list right now, and that's the warning I'm getting, is it's worried about, hey, do you want to specifically type what kind of array list? And you can. So right now this is a very, very generic array list. We're going to use generics. So this is the syntax of telling the type of array list it's going to be. So we've never seen this syntax before. But right after the word array list, if you put a less than symbol, a greater than symbol, and in there you put the type of things that you're going to store in the array list. Okay, this is called generics. And now everything that comes out of the array list will come out as a string. Before, everything that was coming out of the array list was coming out as an object, and I cannot store it into a string. That was the error message I was getting there. So I also need to put this over here. So something to note to yourself is knowing that this right here, you have to put the type of thing that you're storing in the array list there, and you have to put the type of thing that you're storing in the array list here, or you should. That's why we were getting a warning before. It's still okay not to. It just may not do what you want it to do. So in this class, we are always going to store the same type of thing in our array list. So we will always put what type of array list we're going to put there and there. So just notice that syntax. These are called generics. So now everything that comes out will come out as a string. So right here, when I set 1 to first, it returns what was in that first index, which was, what did I have in there, bozo or whatever. It will return that as a string now, so now this will be okay. When I compile this, it'll say, you don't have any errors. Before I was getting errors because when I was taking that item out and trying to store it as a string, it was like, oh no, it's not a string. It's just a generic object. And we haven't got into the object tree yet. But just note that when you build an array list, you should, and we will in this class, put the type of thing that we're going to put, or we're going to put in there right there. Okay? So this should now work. Everything should set. So just know all those methods that we went through. I'm just going to build another one just to kind of talk about some other things. What if I want to build an array list that stores numbers? So scores or something like that equals new array list. And this is a generic. Notice I didn't put the less than or greater than there, but you say, oh, I want to store them as ints. I want this to be an int array list. I want this to be an int array list that stores ints. And we're going to get an error message, or I hope we get an error message here. Yeah, it says it can't do that. You can only build array lists of objects. Array lists can only store objects. And remember, ints, doubles, chars, booleans, those are not objects. Those are primitive types. So you can't, you're like, well, I can't build an array list of ints. You actually can, because Java then developed what is called wrapper classes. And that's not like somebody straight out of Compton. That's a wrapper class is W-A-R-A-P-P, and it wraps things up. And there's a wrapper class for every primitive type. So there is an integer class, and there is an integer class. And all the integer class does is take primitive types, or int. So if I come over here, if I had like int x equals 4, it's terrible handwriting. Remember what that does is it gives you a memory location called x that has a number 4 in it. They're stored in the same location. All a wrapper class does is take that 4 that used to be primitive and wrap it up as an object. Okay, so it takes this primitive number 4, wraps it up as a massive object. So now you can have a different variable, and we'll do that in a second, but it's wrapped up as an object, so it has methods that you can use and variables and all that kind of stuff, and it has a pointer now, so now the x and the 4 are stored in different locations. So it's wrapping primitive types up as objects. So that's what integer, it's a class in Java that wraps up things. So now, and this is where I actually don't like that Java takes care of you, if I wanted to add something, I could say scores.add, and I could say 4. Now this should be illegal in my opinion, but this will compile fine. It'll say you're the best, and there won't be anything wrong with that. I don't like that because you really shouldn't be able to add an int. You should be able to add an integer, but not an int. But what Java does is auto box. And it does this, I don't even remember what year it started doing this, but it will auto box primitive types. That means it will take a primitive type, and if it's expecting an object type, it will automatically box it into an integer. So 4 is automatically boxed into a integer, and therefore it's added to the array list, and we're good to go. Okay, what you really should do, and I'll just do it again, is scores.add, and if I wanted to add the number 7, I should say new integer and pass the number 7 to the constructor of the integer class. That's like the formal way. If I compile that, that's really the way we should do it if we actually know what we're doing. But Java will take primitive types and automatically box them into object types for us if we don't do it like this. This is actually creating an object of the integer class, passing the primitive number 7, and then it's creating an object from 7. So both of those things, Java just takes care of you. It hooks you up for those things. All right, so the array list class is absolutely amazing. It keeps track of everything for you. It has, you can look at the methods in the API. The main things that you have to know is the 2 add methods, the remove method, the set method, the get method, and the size method. You will have a chance to play with those, and you got to know that when you build an array list, you have to type it so that when the things come out, they come out as these things. And I'll talk about that more in class. We'll do some more examples of that. If we don't put the type there, what really will happen. Okay, so all of this stuff is you'll be responsible for. You can read from the book from it as well. The new assignment we'll be doing, and I'll put it on the Google Classroom, is the shopping cart doing the shopping cart again, but now using an array list instead of an array of items. So remember, I guess I better show that real quick. We could build an array list of items right now. It would be an item array list, like so. Okay, and we could call it cart if we wanted to, equals new array list, type of item, and then you still have to, this is what always gets me every year, I have to go back and review, where does that item go? So this is really a call to the constructor of the ArrayList class. There is a default constructor, that's why there's no, nothing inside those parentheses, but you put the type, or the generic right in there, or the specific, I should say, right there, so after the class name, before the two parentheses for the constructor. Just know that syntax. But this would now allow me to store items into the cart. So I could say new item and just slap it right in there, and it would manage everything for me. All right, so you can check out that assignment. We'll answer any questions in class, but that's the ArrayList class. Hope you enjoyed our time together.